So here is the new section, section 1.1, part 1. 1.1, part 1. Because we're going to study part 2 also, which is how to solve linear equations. If you remember yesterday, I told you about the like terms, how it's going to be the like terms, which is important because we're going to combine the like terms here before solving the linear equations. So like terms, if you have, let's say like terms, if you have just number by itself, like 3, -2, 5, 100, 150, -120. You see all these just number by itself, a number by itself. So we can call these like terms. So for example, if we have -2 plus 5, you see I have just number by itself and number by itself, so I can combine these together. Here's another example, like terms. We have 3x, -4x, 5x, 100x. Now we have number with the variable, number with variable, number with variable. And if you check the variable, it's x with exponent 1, x with exponent 1. So we call these like terms. For example, if we have 2x plus 6x, I can combine these together because a number with variable, a number with the variable, and we have exactly the same variable. So we can call these like terms. So the result here is going to be 8x. The third part about the like terms, let's take another examples about the like terms. If we have 6x squared, -2x squared, 5x squared. Now we check 3x squared. We have a number with variable with the squared. Exactly the same thing here. A number with variable x and squared. A number with variable x squared. A number with variable x squared. So if we have 6x squared plus 3x squared, these are like terms because number with variable squared, number with variable squared, like terms, exactly the same variable, so I can combine these together. So it's going to be 9x squared. Be careful. When you're adding and minus the like terms, you're not going to do anything with the variable. Check the variable, exactly the same. The same variable. You're not going to add the exponent. You're just going to add the coefficient. 6 plus 3, 9. These are the like terms. We're going to use it when we solve the linear equations. Now, let's start with the first part about the linear equations. The first part of the linear equations, I'm going to write down number 1. The first part of the linear equation, how to solve linear equations of the type x plus b equals c. X is the variable, b and c numbers. Okay. X is the variable and b and c are numbers. So this is the first time we will learn how to solve this kind of linear equations. For example, if we have, you see, x plus 3 equal 5. You see, this is exactly the same here. This is the first time. Keep in your mind, the main thing when we need to solve the linear equations, we need to find the value of x. That means x is going to be equal a number. That means this is the solution. How are we going to solve this one? The easiest thing, we're going to move, keep this notes in your mind if you want to write it down, move all the numbers, the number by itself to the right side, and move the variable to the left side. I have only the variable here exist on the left side. So I'm going to move the number to the right side. How are we gonna move? This is a +3. I'm gonna say -3. -3 from both sides. +3, I need to move this 3 to the other side. So I'm gonna say -3 from here, -3 from the other side. Now, 3 minus 3, this is 0. That means we're gonna cancel these two numbers. The leftover from the left side, just the x by itself. And here's the equal sign. 5 minus 3 is going to be 2. This is the solution. So keep in your mind, always we're going to move the number to the right side and keep the variable to the left side. The general rule is to move the numbers to the right side and move the variables to the left side. I don't have variable here. The variable is already exists on the left side. That means I'm going to keep the variable here on the left side, move the number to the right side, -3 from both sides. So x is going to be equal 2. This is the first kind. We're going to solve more examples about this type of linear equations. Okay, go ahead.
So if it's on the other side, are we gonna add it on the other side?
Which one? You're talking about this side, the right one?
Yes, if it happened to be there, then would we add it on the other side?
Oh, if there's a number here,
Yes.
yeah, we're just gonna combine with this number. Like for example, I know what you're talking about. Like if you have x plus 3 equal 5 plus 2, like this.
Yes.
You're gonna add these two numbers because they are on the same side and they are like terms. Number by itself, number by itself. Okay.
Sir, I don't get how are we going to move it to the left and change the plus and the negative.
Yes, because when it's that's mean here's the equal sign. You're gonna take the number from this side and move it to the other side. So always when it's a +3, you're gonna say -3 from both sides. When it's -3, you're gonna say +3 from both sides. We'll see in another example, and we're gonna solve like this example also. So don't get hurried. We're doing step by step. So if you have like this example, you see I have +3. I need to move this number to this side. I have a +3 here. So what I'm gonna do, I'm gonna say -3, -3. Okay? That's the first rule we will learn. You're gonna do the opposite side, the opposite sign. +3, you're gonna say -3. And you're gonna say -3 from the other side. Let's do another example so you understand the whole thing. If you need to write down everything here, let me know before we move into the next page. So here's another example. If we have x minus 16 equal to 20. So you see, I need to move the numbers to the right side and keep the variables on the left side, because these equations look like x plus b equals c is exactly the same thing. X plus or minus a number equal a number. So we're gonna solve exactly the same thing here. Check, I need to leave the variable here by itself on this side, the left side, and move this number, because it's number by itself, to the other side. It's -16, -16. So what I'm gonna do, I'm gonna add 16 here, and I'm gonna add 16 here. So now, x, here is the x. -16 or +16, how much is going to be? -16 plus 16 is going to be 0, right? Yes or no?
Yes.
So that's mean we're gonna cancel these two numbers. Equal 20 plus 16, 20 plus 16 is going to be 63. That's it. X equals 63. Sorry, 36. X equals 36. That means this is the solution. The solution for this linear equation is x equal 36. Keep in your mind, the general rule is to move all the variables on the left side and the numbers to the right side. When you need to move the variable or the number, just add or minus, do the opposite sign. Let's do another example. Now, if we have 7 plus x equal 5. So now, which one I'm gonna move? I'm gonna move the x or the 7?
The 7.
The 7. The sign for the 7, there is no sign here. That means it's a plus. So I'm gonna say minus 7 from here and minus 7 from here. Seven minus 7 is going to be 0. So the leftover from the left side is just the x equal 5 minus 7 is going to be -2. This is the result. X. Now, if you check the result, x exists on one side and the number exists on the other side. That's mean x equal -2. This is the solution. X equal -2. Who has a problem with this type of equations before we move into the next type? Now check the first type. There's a sign between x and the number, always. The second type, which is if we have a x equal b. This is the second type. A and b are numbers. Like number and number, and this is the variable. We need to find the value of x. If there is no sign between the number and the variable, that means it's multiplication. For example, if we have 3x equal 9, 3x equal 9, how are we going to solve this one? So this is exactly the same thing. Here's the a, this is the variable, and here's the b. We need to solve this one to find the value of x. If you check the sign between the 3 and the x, it's multiplication. So now, I'm not going to add or minus. I'm going to divide. If the sign between the number and the variable multiplication, you're going to divide both sides by this number here. So you're going to divide both sides by 3. You're going to say this is divided by 3. This is divided by 3. Now 3 divided by 3 is going to be 1. The leftover from this side is going to be just the x by itself. On the other side, 9 divided by 3 is going to be 3. You see, we get x on one side by itself and the number on the other side by itself. That means this is the solution.
Sir, so when there's no sign between them, it's going to be a multiplication, and we're going to divide.
Always, always. When you have like 3x or 2x or 2x squared or 5x squared, what's that mean? That means the sign between the number and the variable is multiplication, okay? That means it's 3 times x. But now you are on the college level, you don't have to write down 3 times x, okay? Just write down 3x, 5x squared, 6x squared, or cubic. It doesn't matter. That means the sign between the number and the variable, it's multiplication, okay? Always keep this note in your mind. Let's do another example. What about if we have -2x equal 3? That means it's -2 times x equal 3. But I'm in college level, I don't have to write down the multiplication. I
Sir,
already know. Go ahead.
sorry, I can see the paper.
1 second. Oh yeah, let's go up. Yeah, tell me when, because I forgot sometimes to move it. So now, if you have 2x, -2x equal 3, we need to find the solution. That means we need to find the value of x. Always -2x, that means it's -2 times x. But I don't have to write down this multiplication sign because I already know it's a multiplication. So what I'm gonna do to find the value of x, I'm going to divide both sides by which number?
By 3.
No, by the number,
By 2. By -2.
by -2. Always you're going to divide by the number beside the variable. Okay, always. So I'm going to divide both sides by -2. Yes, not by 2, because this number here beside the variable is -2, and this one by -2. Now -2 cancel with -2. The leftover here is just the x equal. You don't have to write it down as a decimal number. This is the solution. Can you simplify it? No. So I'm just going to write down 3 over -2. Keep it like this. This is the solution. Keep it as a fraction. 3 over -2. If you convert it to decimal, it's going to be right. But sometimes when you're doing the homework online, they're going to tell you it's wrong. Write down your solution as a fraction. So keep it as a fraction. Can you simplify it? No. That's it. That means this is the solution.
By 4.
You're going to divide both sides by the number with the variable. So you're going to divide both sides by 4. So tell me, let's write down here. Cancel the 4 with the 4, the leftover just the x from this side. Now -36 divided by 4 is going to be
-9.
negative what? 5?
Oh, no. I mean, 9.
9, -9. This is the solution. Because sometimes on the online homework, you will get x equal like this. Okay, so you're just gonna write down -9 here. Sometimes they're gonna ask you to write down the solution. They're telling you the solution. This is important. Sometimes you can write the solution, but you're gonna plug in the wrong one. And they give you 2 parentheses. So if they give you x equal a square, you're just gonna write down the -9. If they're telling you the solution equal 2 parentheses, you're just going to write down -9. You don't have to write down here x equal -9. They're gonna tell you it's wrong. So be careful on the online homework. If they're telling you x equal -9, or x equal square, you're just gonna put -9 here. If they're telling you the solution equal and there's 2 parentheses, you're not gonna write down x equal -9. You're just gonna write down -9.
Sir, when we are going to do our online homework, it has to be down by the lockdown browser.
No. The online homework is not about the lockdown browser. Like, this is good question. Let me share this page with you. So when you go to the modules, you see, this is the first, we studied this one yesterday. This is the notes. Here is the first homework. You're gonna click on it. You're gonna open on the new page. This is the homework, okay? Just gonna work on these examples, okay?
Okay.
It's a homework, it's a practicing. I'm not gonna punish you or like, I'm gonna help you to do these examples. If you need help, just take a picture and send it to me through Canvas. So this is the first one. You're gonna go back again, and here is the second homework. You see? Click here, it's gonna open a new page. This next section, here is the homework. This is a video. This is the note, sorry. Video, and here is the first homework. This is the second homework. Today, we're going to study this section, and this is the homework, okay? You're gonna click on it, open a new page, and work on these homeworks. You see, I post also videos here if you need help, and here is the examples. The main thing with the examples, if you work on the examples, the test is going to be super easy for you.
And for the test, we can use just calculator.
You can use calculator, yes. The app I told you to download,
Yes.
and also on the test, you will see a small calculator on the side. I'm gonna post it during the test. You will see a small calculator on the side. You can use it.
Sir, and for Lise, we're going to on the test. We can use like notes of like how to not how to do
Yes.
it, the form
Yes.
of the form or like that.
Yes, you can use notes.
Okay, thank you.
You can use the notes, exactly the notes. I'm gonna write it down for you. You can use it on the test. That's why I'm telling you, practice on the online homework, because the test is going to be easier for you. Because it's gonna be exactly the same examples. Just it's gonna be change in numbers. It's exactly the same way to solve it. Now let's start with the third type about how to solve the linear equations. The third type is if we have ax plus b equals c. This is the third type. Ax plus b equals c. Again, a, b, c are numbers. How are we going to solve this one? Let's take an example. 4x plus 2 equal 10. You see, this is exactly the same type here. This is a number, x plus 2 equal 10. How are we going to solve this type of equations? The first thing, always, you're going to start, I told you this notes. Write down this notes. Move all the numbers by itself to the right side. And move all the variables to the left side. Move all the numbers by itself to the left side, so to the right side, and move all the variables to the left side. Check, I don't have variables here, and the variable here is already exists on the left side. So the first step, I'm gonna move the numbers by itself to the right side. Plus 2, how I'm going to move the plus 2 to the other side? Someone tell me.
It's minus 2.
Minus 2 from both sides. So you can say minus 2 from here, minus 2 from here.
Sir, and the 4 there is before the x. That is.
Yeah, the 4x, we're gonna leave it to the next step. Okay?
But the 4 that 4 is gonna be by itself, or it's with
No,
the
no,
variable?
the 4 is not by itself. The 4 is with the x. You see this, the 2 by itself. There is no variable here. That means this a number by itself is not a number with the variable. Okay?
Okay.
So move, how are you gonna move? This is the first step. Always when you see equations like this one, you're gonna move the number to the right side, and the variables, if there is a variable here, we're gonna move it to the left side. So how are we gonna move that plus 2? We're gonna say minus 2 from both sides. Tell me what's the leftover on the left side. 2 minus 2, 0. Okay, what's the leftover here?
4x
Write down 4x here.
equal 8.
Equal 8. 10 minus 2 is going to be 8.
8.
Now tell me, what we need to find, we need to keep the x by itself, okay? We need to keep the x by itself, but there's a 4 here.
We're
What's-
going to. Sorry.
Go ahead, go ahead.
We're going to divide the x
We
over the 4 to get the x.
by itself, perfect. Because the 4 is the meaning of the 4x, it's 4 times x. So I'm going to divide both sides by 4. 4 cancel with the 4. The leftover here is just the x by itself. Equal 8 divided by 4 is going to be 2. You see now, we have just the x by itself on the left side, and we have a number on the right side. That means this is the solution. We're done from this example. If we have 3x minus 4 equal 5. You see, it's exactly the same thing. The first step, I'm always going to do these steps. First step, move all the numbers by itself to the right side. Where is the number by itself? -4. I need to move -4 because it's by itself to the right side. It's -4, so I'm going to add 4. -4 plus 4 is going to be 0. The leftover from the left side is just the 3x. Equal 5 plus 4 is going to be 9. Next step, I need to leave the x by itself. The sign between the number and the x is multiplication. So I'm going to divide both sides by what?
By 3.
By 3. 3 cancel with the 3. The leftover from this side is x equal 9 divided by 3 is going to be 3. That's it. This is the solution. We're done from this example. You have questions you can ask before we move in to the next one. So the next type about how to solve linear equations. Type 4, if we have ax plus b equal cx plus d. A, b, c, and d are numbers. You see, this is the variables, x, and all these are numbers. How are we going to solve if we have this type of equations? We're going to use the same rule. Move all the numbers to the right side and all the variables to the left side. Let's do an example about that. If we have -5x plus 4 equal x minus 7. So here's my rule. Move all the numbers to the right side. And then we're going to move all the variables to the left side. I'm going to start with numbers. I'm going to move the numbers by itself, which is the 4. So I'm going to move the 4 to the other side. So I'm going to say -4, -4. This is the step 1. 4 minus 4 is going to be 0. The leftover from the left side is -5x. Here is the equal sign. the leftover from the right side. X -7 minus 4 is going to be -11. Now we did step 1. Step 1 is to move all the numbers by itself from this side to the right side. Step 2, we need to move all the variables on this side to the left side. So move all the variables to the left side. Here we have X. How are we going to move the X to the other side? Who's gonna tell me?
Adding X.
Because it's positive X. There is no sign here. That means a plus X. So we're going to do what? And instead of adding X, you're gonna say what? It's positive X. That's mean a plus X here. So you're gonna say what? Minus X. Minus X. Here's just X by itself. What's that mean? The sign for the X is what? It's positive. So we're gonna say minus X from the both sides. X minus X, how much is going to be? X minus X. If you have
Positive.
no, I'm talking about if you have X and I'm gonna take from you an X. What's the leftover with you?
An X?
Nothing. If you have an iPhone and I'm gonna take the iPhone from you, what's the leftover? With you, what's the leftover?
Nothing?
Nothing. This is an iPhone. I'm gonna take the iPhone from you. What's the leftover? Nothing from the X. X minus X, that means 0. Now on this side, minus 5X, negative 5X minus X. I'm gonna ask you here on the side before we move on. If there is just X by itself, how much the number here? You can add this with your notes. If there is no number here, that means the number here is 1, okay? So if you have negative X, what's the number here?
1.
Invisible, yeah, invisible 1. Okay, let's do it here. There is no number here. That means how much the number here? 1. That means you have 1X. And here is another 1X. If you have 1X and I'm gonna take it from you 1X, what's the leftover? Zero. You get that or no?
Yes,
Yes or no?
I do.
Yes.
So let's go back here. Negative 5X minus X, how much the result here?
Negative 6?
Perfect, because there is an invisible 1 here.
Sir,
Negative 5
I had a
minus
question.
1. Okay, go ahead.
When the signs are equals, it's going to be an F?
And add. If you have the same sign, you're gonna add the numbers. 5 plus 1 is going to be 6, and here's the X. By the way, here you don't have to do mistakes because you can use the calculator. Here's my phone. To make sure you got the right solution, you're gonna say exactly the same thing. 1 second. Like here. You're right. When you have the same sign, you're gonna write down the sign and you're gonna add the numbers. To make sure you got the right number, you see this? This is the negative sign, not the minus. Here's the negative sign. Negative 5 minus 1. How much is going to be? Negative 6. I don't know if you can see it or no. You see? Negative 5 minus 1 is going to be negative 6. The negative sign here, and here the negative sign with the parentheses, and here is the minus. To make sure you got the right answer. To check your solution, you can do these steps. Now negative 6x, here's the equal. What's the leftover from the right side? Negative
11.
negative 11. Now who's gonna tell me the last step? I need to leave the x by itself.
We have to divide negative x by negative 11.
We're gonna divide both sides by which number?
By 6.
By
By
negative.
negative 6.
So negative 6 cancel with the negative 6. The left over here is just the x. What about the other side? Can I cancel the negative sign with the negative sign? Is that right? The solution is going to be 11 over 6. Because here, another note. Negative divided by negative is going to be positive. So negative 11, negative divided by negative is going to be positive. Positive divided by positive is going to be positive. Negative divided by positive and positive divided by negative is going to be both negative. So check here. I have negative divided by negative. How much the result is going to be? Positive. 11 over 6. I can't simplify it, so I'm going to leave it as this. So this is the solution. We're going to do more examples about that, so it's going to be easier for you.
Sir, and when we divide negative 11 over negative 6, it can be decimals, or we have to just leave the fraction like that.
Okay. When you write down as a decimals, it's going to be right. But on the homework, the online homework, or sometimes on the test, they're going to ask you to write down your solution as a fraction, not a decimal. So you have to write down the solution like this. Okay. If you're doing the test on paper, if you write down the answer for me as a decimal, I'm gonna give you a full mark. But on the test, we're going to do the test online. So you have to write down the solution as a fraction, because they're gonna ask you to write down the solution as a fraction. So always you have to check when you get the solution as a fraction, if you can simplify it. If not, that's it.
Because when we do on the last example, that we divide to get the individual x by itself, we will divide 9 over 3, and then we get
3.
And then we get the x by itself as a 3, and we cannot do the same thing on this example, the last one, like 11 over 6, and it will be negative 5, I think so.
Because it's going to be negative 5 point. It's going to be, go ahead, divide it. It's going to be the same number. Divide negative 11 by negative 6 is going to be 5.5.
It's because on the calculator that I had, the one from the app, it just gave me negative 5. That's why I didn't.
Oh yeah, so you have to fix it. You're right. But when you divide 11 divided by 6, it's going to be 2.2. You see? So are you using exactly the same app? How you get 5?
So it will be a negative 11.
Okay, negative 11 divided by negative 6. Okay. How much you got? 1.8333, like this?
Yes, 1.833.
You see, so that's why this is the right solution. But on the test or the online homework, they always asking you to write down your solution as a fraction. Okay? So when you write down on the test 1.8333 is going to be right. But the program for MyLab Plus, they're not going to accept the solution as a decimal. They always accept the solution as a fraction. Okay? Let's do one more example so you learn how to do these steps. And keep one thing in your mind: when there's no number beside the variable, Like here's x. There's no number here, that's mean 1. If you have negative x, that's mean always the number here is 1. When you combine the like terms, like negative 6x minus 1x, I'm just going to add or minus the numbers here. I'm not going to do anything with the 6, with the x. Here's the x. Negative 6 minus 1 is going to be negative 7. Just add the coefficient. The variable is going to be exactly the same thing here. Let's do another example, the first example on the workbook, so you can practice more. We have negative 7x minus 4 equal x minus 7. Is that the same one? I don't know. So how are we going to solve this one? We're going to do exactly the same steps. Move the numbers. I'm going to look always to this side. I'm going to move the numbers by itself to the right side. So how am I going to move negative 4? We're going to add 4. So I'm going to add 4 here. I'm going to add 4 here. Negative 4 plus 4 is going to cancel. The leftover from this side, negative 7x. Here's the equal sign. The leftover from the other side is x. Negative 7 plus 4 is going to be, is that right?
Yes.
Now, what's the next step?
We're going to divide by negative 7 both.
No, before that, you
You
have
gotta
to
cancel
move.
the x's.
Yeah, you have to move the variable to the
Left.
left side. So how are we gonna move the x? What's the number here? The number here is 1.
Negative 1x.
Perfect. So you're gonna say minus 1x from both sides.
Yes.
Minus 1x from both sides. Now 1x minus 1x is going to be 0. Negative 7 minus 1 is going to be what?
Negative 8x.
Negative 8x. Because negative 7 minus 1 is going to be negative 8. I'm not going to do anything with the x, just write it down. Here's the equal sign. What's the leftover from this side? Negative 3. Now, what's the last step? You're going to divide both sides by which number?
Negative 8.
Negative 8. You're going to divide both sides by negative 8. Negative 8 cancel with negative 8. The leftover just the x equal negative divide by negative. The result is supposed to be positive. So negative divided by negative is going to be positive. And can you divide the 3 by 8? It's going to be decimal number. So just keep it as a 3/8. That means this is the solution, it's a fraction. Solution is a fraction, positive 3/8. Which is, I'm just going to add extra steps. Six R. Now the variable is R. Plus 9 equal negative 2 minus 5R plus 5R. You see, I have variables here and variables here, number and number. Before always we start, we have to make sure I have only one variable, one number here. One variable and one number here. So the first thing I'm going to start to do when I solve this example, combining like terms. I'm going to ask you, these are like terms? Yes or no?
No.
No,
No.
because they are not like terms, because this is a number with a variable, this is a number by itself. Tell me on the right side, do we have like terms?
Yes.
Yes. Check here. This one, exactly the same thing here. So these are like terms. If we combine these two terms, how much the result?
Negative m
10.
n by itself.
No, because be careful. It's -5, a +5.
Would it just be R?
Which is okay. You said R, but
Zero.
-5, a +5, how much?
0.
So 0 R, right?
Yes.
So 0 R. What's the operation between 0 and R?
R, just R.
No,
Oh no, because R is
Does it
R is
cancel out the
one.
one?
1 second, step by step. So when we combine these together, it's going to be 0 R, right? Yes or no?
No, because
Yeah.
you have nothing left.
Oh, perfect. But before, I need to do it step by step so you can understand the whole thing. Because when you add the coefficients, -5 and +5 is going to be 0, right? And here's the R. Now tell me, what's the operation between 0 and the R?
R
Is this-
squared? No.
No, it's the same thing. What's the operation between 3 and X?
Multiplicate.
Multiplication, okay. What's the operation between 0 and R? Is multiplication?
Yes, because it's a number and then it's the variable.
Okay, so if you multiply 0 by any number, what's the result?
0.
Perfect, 0. That means you don't have to do all these steps. When you have -5R, a +5R, -5 +5, that means just cancel it, because we already know the result is going to be what?
0.
0. So you don't have to do these steps. So always when you have -5R + 5R or -5X + 5X, just cancel it and that's it. Now tell me, the left side is 6R + 9 equal, what's the leftover here? -2. Now can we solve this one? What's the next step? Which one I'm gonna move?
Times both sides by 9.
Cancel.
So you're gonna move the 9 to the other side by -9, -9. 9 minus 9 is going to be 0. The leftover from this side is 6R equal -2 minus 9 is going to be -11. Now, what's the next step?
Divide both sides by 6.
Divide both sides by 6. 6 divided by 6 is going to be 1. The leftover is just the R. You see, 6 divided by 6 is going to be 1. It's the same thing, the invisible 1 here. So I don't have to write it down. Equal -11/6. If you divide -11 by 6, it's going to be decimal number. So I'm going to write down the solution as a fraction. Let's do the next one. We have 6 parentheses 2x minus 1 equal 24. So before we start, remember when I told you always, when you have a number with parentheses, what are we gonna do?
Multiply.
Which is distribute, right? So we're going to multiply this one here, and we're gonna multiply with the second number. So always, when you see a number with parentheses, you're going to distribute. How? By multiplying the number here, because the same thing, it's multiplication. You're gonna multiply the first number with the first one and the first number with the second one. So 6 times 2 is going to be 12, and here's the x. 6 times -1 is going to be
-6.
6, equal 24. Is that the same one we solved before? Exactly the same one. The same one with different numbers. So I'm going to move the number to the right side. -6, I'm going to add 6. -6 plus 6 is going to be canceled. That means 0. The leftover here is just the 12x. Here's the equal. 24 plus 6 is going to be 30. The next step, you're going to divide both sides by
12.
12. Sorry. Don't know why I write down 30. So 12 divided by 12 is going to be 1. The leftover, just the x, equal 30 over 12. So how much is the solution? X equal what? Thirty divided by 12. Can I simplify it?
Yes.
Divide both by side by what?
By 2.
Okay, that's good. We're gonna start with 2. Divide by 2 and divide this one by 2. 30 divided by 2 is going to be 15. 12 divided by 2 is going to be 6. Can I simplify it more?
Yes, by 3.
3, perfect. So divide by 3, divide by 3. X is going to be equal 15 divided by 3 is going to be 5. 6 divided by 3.
2.
Can I simplify it more?
No.
No, this is the solution. That's it for this example. Someone tell me what we're gonna do on this side.
You're gonna multiply first?
Multiply.
So we're gonna multiply these, distribute, and we're gonna do the same thing here. We're gonna distribute the 5. So keep in your mind, always when you see parentheses, and there's a number, you're going to distribute the number. Keep this notes in your mind. So I'm gonna say 3 times 2 is going to be 6z. 3 times -5 is going to be -15, equal 5 times z is going to be 5z. 5 times 4 is going to be plus 20. Now, next step, I need to move the variable to one side and the numbers to the right side. So move the numbers by itself to the right side. -15, I'm gonna add 15. I'm gonna add 15. -15 plus 15 is going to be 0. The leftover here on the left side is 6z, equal. Here on this side is going to be 5z plus 20 plus 15 is going to be 35. Now, what's the next step? I need to move the variable from here to the left side. So 5z. How I'm gonna move it to the left side, I'm going to say minus 5z from both sides. Minus 5z minus 5z. 6z minus 5z is going to be 1z. That's why I don't have to write down the 1 because it's 1z. So always if there's no number, that means it's 1. That's why you don't have to write down the 1z. Equal 5z minus 5z is going to be cancelled. That means 0. And the leftover is 35. Z equal 35. The variable on the left side and the number on the right side. So this one is the solution.
Sir, we always have to move the variable to the left.
Yes, always move the variable to the left and the numbers to the right. So you will have a basic to solve these examples. You can do the opposite things, going to be fine, but I don't want to confuse you. So always move the variable to the left side and the numbers to the right side. About here, let's do this one. This is example 6 in the workbook. We have y minus 8. Put star on this one. This is important. Minus y plus 4 equal 7y. Now tell me here. What's the first step? We have to do it on this parentheses. What's the number here?
1.
1. Every time when there is no number, it's 1. 1 times y, we're going to distribute the 1. I'm going to write down invisible 1 here. We're going to distribute this one here. 1 times y is going to be y. 1 times negative 8 is going to be negative 8. We've done it from the first parentheses. What about this one? What's the number here?
-1.
Perfect. So you're going to write down 1 here, but don't forget there is a sign here. So it's -1. So now I'm going to distribute -1. -1 times y is going to be -y. -1 times 4 is going to be -4. Equal 7y. Now tell me here, do we have like terms? Y minus y, is these are like terms?
Yes.
So y minus y, how much the result?
0.
0. That's mean cancel this one with this one. -8 minus 4, how much is going to be?
-12.
So here is -12. So -12 on this side. What about the other side? 7y. Now tell me, I'm going to put a star on your name if you tell me what's the next step.
We have to divide
Divide by what?
the 7y over -12
So, okay. So we have to divide both sides by which number?
by -12.
No.
Oh,
7y.
So you can divide both
By
sides
7.
by 7. Okay, so I'm going to put a star on 3 names. That's good. So always you're going to divide both sides by the number beside the variable.
okay.
Not by this side. You see, what's the number beside the variable? 7. So I'm going to divide both sides by 7. 7 divided by 7 is going to be 1. The left over here is y equal negative 12 over 7. You can't simplify it. So this is the solution, negative 12 over 7. So you see, it doesn't matter if you have the variable on the right side. The main thing, I need to get the variable by itself. There is no number here. There is no number under the y here. No, just the y by itself on one side and a number by itself on the other side. So that's the solution. Put the star on this example because this one is important. And keep in your mind, always when I'm telling you this is important, that means this is important. It's going to be maybe on the test. Let's do one more example, and I'm going to give you a rest. Let's do this one. It's exactly the same process. Now, from now until the end, the same process. 3x minus 7 minus 7 parentheses x plus 1 equal negative 6x plus 3. Now the next step here, what we're gonna do, I have parentheses. Can I multiply this number here by the parentheses? Yes or no?
Yes.
So always when you see parentheses and there is a number, you're going to distribute the number. So here's a 3x minus 7. Negative 7 times x is going to be negative 7x. Negative 7 times 1 is going to be negative 7. And here's the equal sign. What about this one? Do I need to distribute the negative? What's the number here?
1. Negative 1.
Yes, always there is no number. That means the number here is 1. So negative 1 times 6 is negative 6x. Negative 1 times 3 is going to be negative 3. On this side, do we have like terms? We have this one and this one. We have to combine these. And we're going to combine the negative 7 with the negative 7. See, I put one line because these are like terms. I'm going to combine these like terms. 3x minus 7x, negative 4x. Because 3 minus 7 is negative 4. And here is the x. You see, I'm not going to do anything with the x. Just write it down exactly the same. Negative 7 minus 7 is going to be negative 14. And here is the equal sign, negative 6x minus 3. Now, next step, we're just going to move the variable to the left side and the numbers by itself to the right side. So here's the number by itself. I need to move it to the right side. Negative 14, I'm going to add 14. Add 14. This is 0. The leftover here is negative 4x equal. The leftover here, negative 6x. Negative 3 plus 14 is going to be plus 11. Positive 11, so I'm going to write down plus 11. Now, next step, you're going to move the number with the variable here to the left side. So negative 6x, I'm going to add 6x. Add 6x to the both sides. Negative 6x plus 6x is going to be canceled. The leftover on this side is just the 11. Negative 4x plus 6x is going to be 2x. Last step, we're going to divide both sides by 2 by the number with the variable. Divide both sides by 2, cancel these 2. The leftover here is just the x equal, I can't simplify the 11 over 2, so I'm just going to write down 11 over 2. This one is going to be the solution. So I'm just going to make you ready for the final. So let's do this example. Example 12, which is 4, 3x plus 5 plus 7, parentheses, x plus 1, close the parentheses, and here's a bracket. Equal 7x plus 5. So we're going to do exactly the same thing. Every time when you have a bracket, you try to simplify everything inside the bracket. So here's the thing. We're going to write down, this is going to be 4, and here is the bracket. I'm going to write down everything because I have parentheses here. And there's a number here, so I'm going to distribute the 7 here on the parentheses. So here's the 3x plus 5 plus 7 times x is going to be 7x. 7 times 1 is going to be plus 7. Close the bracket, and here is the other side, which is 7x plus 15. Sorry, plus 5. So next step now, we're going to combine the like terms here inside the bracket, inside the brackets. 3x with the 7x and 5 with the 7. I'm not going to do anything with the 4, just write it down. 3x plus 7x is going to be 10x, because we're just going to add 3 plus 7, 10. I'm not going to do anything with the x. 5 plus 7 is going to be 12. Close the bracket, and here is the other side, which is 7x plus 5. Now, next step, I can combine these because they are different terms, but I have a number bracket. Every bracket is exactly the same parentheses, so don't confuse yourself. So we're going to distribute the 4 on both these inside the bracket. 4 times 10 is going to be 40x. 4 times 12 is going to be 48 equal 7x plus 5. Now this is the basic equations. How we're going to solve this one? We're going to move all the variables to the left side and the numbers to the right side. So I'm going to move this number to the right side. It's plus 48. I'm going to say minus 48. Minus 48. This is going to be 0. The leftover from this side is 40x equal 7x minus 43. Because 5 minus 48 is going to be 43. Next step, I'm going to move the 7x to the left side. So minus 7x minus 7x. This is cancelled 0. The leftover from this side, negative 4, 3. And 4 minus 7 is going to be 33. So 33x equal 43. Last step, we're going to divide both sides by the number beside the variable. So divide by 33. Divide by 33. This is 1. We left over just the x equal negative 43 divided by 33. Can you simplify this one? Yes or no? So now we're going to start section R3 over R6, which is the exponents. We already took some idea about the exponents before. So if we have two to the exponent 3, this is called the base, and this one is called the exponents. Again, we're not going to multiply these two numbers because it's going to be wrong. The meaning of 2 to the power 3, that means this number multiplied by itself 3 times. So it's going to be 2 times 2 times 2. So the result is going to be 8. 5 squared. You're not going to multiply these two numbers. It's going to be wrong. This is the base. This is the exponent. That means this number multiplied by itself 2 times. So it's going to be 5 times 5. The result is going to be 25. 4 cubed. You're not going to multiply these two numbers. It's going to be wrong because 4 times 3 is 12, which is wrong. That means the 4 multiplies by itself 3 times. So it's going to be 4 times 4 times 4 is going to be 64. Because 16 times 4 is going to be 64. That's the main thing with the exponents. Let's do some rules to make everything easier for us when we work with the numbers. The first rule of exponent is the first rule. When we have a number with exponent m and times exactly the same number with different exponents. You see, we have a number a with exponent m. This is in general. I'm writing down the general rule so we can use it. And the same number with different exponents is going to be equal. And then the number, you're just going to add the exponents. This is the first rule. Let's do an example about that. If we have 3 to the power 6 times 3 to the power 7. We're going to get 8 or 7 rules. You have to know all these rules. This is the first rule. You see, I have number with exponent 6 times another number, but is exactly the same base with exponent 7. So what I'm going to say this is equal. Here's the number 3. I'm going to add the exponents. I'm going to say 6 plus 7. So the result is going to be 3. 6 plus 7 is going to be 13. Now you can use the calculator. This is the right solution. Go ahead, use the calculator. How much is going to be 3 to the exponent 13? If you don't know how to use it, first of all, you have to download. For those that didn't attend the last 2 days, the last 2 lecture, download on your iPhone, calculate 84. This one, calculate 84, so we can use it the whole time. So here's calculate 84. I need to plug in 3 to the exponent 13. I'm just gonna maximize everything so you can know. So I'm gonna type 13. Sorry, 3. And here's the exponents. The exponents here under the clear. Here's the exponents. So I'm gonna press the exponents and then type the 13. Press the exponents, you see now, and type 13. So the result is going to be 1,594,323. 1,594,323. It's a really big number. The main thing here, I don't need to use to find the result how much. The main thing here is how to use the rule of exponents. So that's the main thing, how to use this rule. We have the same base, different exponents. So I'm just gonna say, here's the number, I'm gonna add the exponents. It's going to be 3 to the exponent 3. The same thing here, the 3 to the exponent 13, it's a number, we can use the calculator. What about if we have variables? For example, if we have x squared times x cubed. The same base, different exponents. Same base, different exponents. I'm just gonna say this is x, 2 plus 3, and this one is going to be x, 2 plus 3 is going to be 5. This is the solution. This is the result. I can't move on. I can't use calculator because x is unknown number. It's a variable. Unknown number or variable. I can't use calculator, so this is the solution. What about if we have like this example? X squared times y cubed. I'm gonna ask you, can I use this rule?
No,
Why?
there's the x and the y.
Because the x and the y, that means you have different bases. That's right. So I can't use this rule because I have different bases. I have to get exactly the same base. You see, 3 and 3, x and x, y and y. So, but here with this one, x and y, so I can't use this rule. This is the first rule about the rule of exponents. So be careful with these two rules. Division, always the exponent on the top minus the exponent on the bottom. And here's 3 examples. Always, you see 3 minus 2 is going to be 1. 9 minus 5 is going to be 4. So x to the power 4. 5 minus 9 is going to be -4. Rule number 3, it's 2 parts. Any number, let's change this one. We can write down here. Any number, there is no exponent, that means the exponent is 1. Like 3, the exponent is 1. X is the same thing, x equal 1. Any number with exponent 0 equal 1. 5 to the exponent 0 equal 1. 100 to the exponent 0 equal 1. X to the exponent 0 equal 1. This is the third rule. Let's move on to the next rule, which is rule number 4. Yeah, let's do now. If we have negative exponents like this one, how are we going to deal with that? Rule number 4.
Is there a 3? I would
Uh,
just do 4.
yeah, this is number 3. We're gonna do number
Okay.
4.
Sure.
So rule number 4, if we have a number with negative exponents, every time when you see a number with negative exponents, you're just gonna say it's 1 over, here is the number, and I'm gonna change the exponent to positive. This is the next rule. Like if you remember on one of these examples, we get x to the negative 4. So I'm gonna say it's 1 over x to the positive 4. 4 to the negative 2 is going to be 1 over 4 to the positive 2. And I can simplify it more because 4 squared, that means 4 times 4 is going to be 16. So when you have number, you have to get the result like this without exponents because they're going to ask you to simplify it. But with the variable, no, you're just going to write down like this. This is going to be the solution. So that's how we're going to work on when we have a negative exponent. Is going to be just 1 over the number with positive exponents. This is the 4th rule. Like this example. Four 8 to the exponent 8 times 5 8 to the exponent 7. You see now we're going to multiply these two terms. Don't confuse yourself with the numbers. The numbers is just multiplication. 4 times 5 is going to be 20. How to multiply these two? 8 to the exponent 8 times 8 to the exponent 7. Which rule I'm going to use here?
Addition.
Which is rule number 1, because you have the same base, you're going to add the exponents. So it's going to be 8 plus 7. So it's going to be 20, 8 to the power 15. This is the solution. So the numbers, I'm not going to do anything with the numbers. I'm just going to say 4 times 5 is going to be 20. Here's another one. If we have, now let's do xy. Negative 3 x cubed y times negative 7 x to the power 4 y to the power 5. Again, with the numbers, we're not going to do anything. We're just going to multiply negative 3 times negative 7 is going to be 21. X cubed times x 4 y times y to the power 5. Can someone tell me how much the exponents here? There's no exponents here. That means how much the exponents here?
It's 1.
1. If there is no exponents, that means the exponent's 1. I'm going to write down 1. So now it's going to be 21 x 3 plus 4 is going to be 7. Y 1 plus 5 is going to be 6. This one is going to be the solution. That's it for this example.
Sir, when are going to be the exponents? When are going to be an F? When are we going to add them? When are we going to add the exponents?
You're gonna add the exponents when it's multiplication between the same base with different exponents. You're gonna add the exponents, like exactly like the same rule number 1. You see, x and x, the same base. So what we're gonna do here? We're gonna add the exponents. So every time when you see a number, multiply by another number with different exponents, like this. When you see this one here, x to the power 3 times x to the power 4. You see, it's multiplication between two numbers, which is the same base, but different exponents. Is going to be x 3 plus 4. Then it's going to be x to the power 7. This is exactly like rule number 1. You're gonna add the exponents when it's multiplication. You're gonna minus the exponents when it's division. Okay? So here is the example. 12 to the exponent 0 is going to be 1. I'm gonna ask you, what about if we have negative 11 to the exponent 0? How much is going to be the result?
1. 1.
Okay. There is a negative sign here.
Oh,
The rule says, yes, the rule says the number with the exponent is going to be 1. Everything here equal 1. But there is negative sign outside, so it's going to be negative 1. There is another one. What about if we have, because you see the exponents here, the 0, it's only for the 11. I'm going to do the same example. Be careful with these examples. But if we have negative 11 to the exponent 0. Now tell me, what's the difference between these two examples? This one, the exponents here, it's only for the 11, not for the negative sign. That's why we're going to write down the negative sign exactly the same. And 11 to the 0 is going to be 1. What about this one? Check the exponents, the 0. For everything inside the parentheses. So how much is going to be the result?
Negative 11?
No, no, the result.
1.
1. Check the difference. Why? The exponent 0 here, it's only for the 11. That's why I'm going to write down the negative sign. 11 to the exponent 0 is going to be 1. But with the second one, the exponents for everything inside the parentheses. For the 11 and for the negative. That's why you're going to write down 1. Here's one more thing. One more example. Negative 11 to the exponent 0. How much the result? The 0 for everything inside, right? So how much the result for here?
Does it stay the same?
It's going to be 1, right?
Yeah, no.
But there is a negative sign outside the parentheses and there is no exponent. So you have to write down the negative sign here. So the result is going to be negative 1.
Oh, shit.
Be careful with these examples. It's like simple examples, but you're going to do a simple mistakes and you're going to lose all the points. And you will get like this on the test. That's why I try to explain all these examples. One more example. So we're going to take the last 3 rules. If we have negative 2 x to the exponent 0, how much the result? You see, the exponent is only for the x. So how much the result here? X to the exponent 0 is going to be 1. And here is -2, so it's going to be -2 times 1, and it's going to be -2. You got this part? Who has a question so far? I know you're tired. So we have 15 minutes. We can do that. So rule number 5 is the same thing. Now we have one number and two exponents. One number and two exponents. One number and two exponents. So we have to multiply these two exponents. So it's going to be a n times m. So that you have to be careful with this rule and rule number 1. Rule number 1, you have two numbers and two exponents. With this rule, we have one number and two exponents. That's why we're going to multiply. Example for that. If we have x cubed to the power 5. So we're going to multiply these. 3 times 5 is going to be 15. So it's going to be x to the power 15. You see, we're not going to add because we have one number, two exponents. So we're going to multiply 3 times 5 is going to be 15. If we have y squared to the power 3, one number, two exponents, so it's going to be y. 2 times 3 is going to be 6. Let's write down 2 times 3. So it's going to be y to the power 6. This is rule number 5. Rule number 6 and 7 is not that much hard. You just have to distribute. So rule number 6, when you have two numbers, a times b, with one exponent. A times b with one exponent, and there's parentheses. You're just going to distribute the exponents on both these numbers. So it's going to be a to the exponent n times b to the exponent n. I'm distributing the exponents for everything inside the parentheses. Example for that, we have x squared y cubed, and everything is, we have to do this one later because this one is 2 steps. xy to the exponents 5. So we're going to distribute the exponents here and the exponents here for both these numbers. So it's going to be x to the power 5, y to the power 5. Have to distribute the exponents for everything inside. So it's going to be 3 to the exponent of 3 times x to the exponent of 3. 3 to the exponent of 3, it's a number. That's mean 3 times 3 times 3. So it's going to be 27 and here is x cubed. That's it for this example. Last rule, which is the same this rule, but it's going to be division. It's the division between two numbers. Rule number 7. If we have a divided by b and everything to the exponents n, so it's going to be a to the exponent n over b to the exponent n. This is the last rule. Example for that, x divided by 2 cubed. You're going to divide the exponents here and on the bottom. So it's going to be x cubed over 2 cubed. And it's going to be x cubed over 2 cubed. That's been 2 times 2 times 2. So it's going to be 8. The same thing if you have just numbers. If you have 2 over 3 to the power 4. Exactly the same thing here. You're going to distribute this one on the top and on the bottom. So it's going to be 2 to the power 4 over 3 to the power 4. 2 to the power 4, that's mean 2 times 2 times 2, 4 times. So it's going to be 16. 3 to the power 4, that's mean 3 times 3 times 3 times 3, 4 times. So it's going to be 81. You can simplify it, so that's it. These are the 7 rules. I need to cover these rules today because tomorrow we're going to take more examples about how to use all these rules at the same time, because they're going to give us an example. You can use 3 rules on it, more than 1 rule at the same time on the same example. That's why I need to cover all these. So more examples about this section, and then we're going to start the new section.